back out here.
Page 318, exercise 5.8. Arithmetic sequence and geometric sequence. Have you figured out the difference between an arithmetic sequence and a geometric sequence? Arithmetic means you add or subtract something to one term to get the next term in the sequence, and geometric means you multiply one term by something to get the next term. So make sure you know that difference, because then when you're looking at an arithmetic sequence, then you say, then I'm looking to either add or subtract something to each term to get the next term. If it says geometric, I'm looking to multiply something to get the next term. And it tells you that problems 1 through 10 on page 318 are arithmetic sequences. So that means, since it says arithmetic, that means we're going to add or subtract something. And see, problem 2 says 3, 6, 9, 12. Okay, so what comes after 12? 15. What comes after 15? 18. What comes after 18? 21. How do I know that? What did you add to 3 to get 6?
3.
Add 3. What did you add to 6 to get 9?
3.
Add 3. What did you add to 9 to get 12?
3.
So if you've added 3 every time, what do you figure you're going to do next?
Add 3.
Just keep adding 3. So 12 plus 3 is 15. 15 plus 3 is 18. 18 plus 3 is 21. 21 plus 3 is 24. 24 plus 3 is 27. 27 plus 3 is 30. 30 plus 3 is 33. And you could just keep right on going, because it's so much fun doing a sequence. Okay? Now, look what they want me to find. A is the first term. So what's the first term in this sequence? 3. You follow that? B is the common difference. The difference between the first term and the second term. And that happens to be plus 3, doesn't it? And then C is the 10th term. So I just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th term is 30. Wasn't that easy? You go, well, I read this chapter, this topic, before I came to class, and they show this cute little formula for finding the 10th term. It's on page 313. A sub n equals a sub 1 plus, comma, parentheses, n minus 1 times d. D is the common difference. So I want a sub 10, so that means that's going to be a sub 1 plus 10 minus 1. See, n is 10 times the common difference. So a sub 10 is the a sub 1, 3, plus 10 minus 1 is 9, times the common difference, 3. Everybody follow that? That's how you use the formula. You go, and sure enough, 3 times 9 is 27, plus 3 is 30. You just found 30. So now, I've just shown you 2 ways to work these problems. You can use the formula, or you can just list them all out there till you get to the 10th one. It's a matter of your choice as to which way you want to do it. If it would have said, find the 5th term, then I would have said a sub 5 is a sub 1 plus 5 minus 1 times the common difference. You follow that? I mean, the one thing they do in this topic is they keep asking for the 10th term. But you know how to find any of the terms. They just happen to ask for the 10th one all the time. So I want you to realize that you don't have to always find the 10th one. If I wanted the 5th term, that would be a sub 5 equals a sub 1 plus 5, 5th term, 5 minus 1 times d. So that would be 3 plus 5 minus 1 is 4 times 3, which is 12. So that's 15. Let's go up here and count. 1, 2, 3, 4. The 5th term, sure enough, the 5th term is 15. You see what happens? So let's do problem number 4. Here's 3, and then here's negative 1. How did I get from 3 to negative 1? What's the common difference?
Minus 4.
Minus 4. Everybody see that? You look at a number line, you go to 3, you go to negative 1, it would be minus 4. Check it out. You go from negative 1 to negative 5, what is it? Oh, I'm doing it for me. I should be doing it for you. Here's 0. Over here is 3. You go minus 4. You're at negative 1. Then you go from negative 1, minus 4. You're at negative 5. You follow that on the number line? So the common difference is negative 4. And what's the 10th term? Now, see, just keep subtracting 4. Negative 5 minus 4 is negative 9. Negative 9 minus 4 is negative 13. Negative 17, negative 21, negative 25, negative 29, negative 33, and there's the 10th term. Negative 33. Now let's check it out with the formula. A sub 10 would be 3 plus 10 minus 1 times the common difference. That would be 3, 9 times negative 4 is 36, negative 36. That equals negative 33. You follow the process? Any questions? Oh, did we forget to do one of the things they gave us to do here?
Yeah, D.
Well, in my book, that's marked out. So you don't do D. You only do A, B, and C. Skip D. It gets too complicated, and it isn't necessary for you to know how to do this process, to do that stuff. If we're not careful, we can make working with a sequence so complicated that you think you can't do it. And you can do it. It's just that when they start doing that theoretical stuff to the nth term, it gets a little complicated, and I've never seen that on a test anywhere. So you don't need to know how to do that. But you do need to know how to do A, B, and C. Number 6. 2/3, 5/6, 1, and 7/6. Now, see, when I look at those fractions, I just don't see it. So I change them to 4/6, 5/6, 6/6, and 7/6. Oh, now I know what comes next. Do you see what comes next? 8/6, 9/6, 10/6, 11/6, 12/6, 13/6, and there's the 10th term. So the first term is 4/6, or 2/3. The common difference is 1/6. You go, how'd you get that? Okay. Let's take these two right here. 5/6 minus 4/6. Find the difference between the first two equals 1/6. So see how I find D? So the common difference is 1/6, and then the 10th term. Let's do the formula just for fun. A sub 10 is the first term, 4/6, plus 10 minus 1 times 1/6. What's 9 times 1/6? 9/6 plus 4/6, 13/6. There we are. Is this too easy? Thank you. Math is not rocket science. It's just math. And you just learn how to do the tricks. Number 8. And I know some of them can, you say, I don't see it. Well, if it's a fraction, rearrange it where you can where you can get it enough common denominator stuff where you can see it. Number 8 says negative 1/4, and then 1/4, and 3/4, and 5/4. So I'm not sure how negative 1/4 fits in here, but when I see 1/4 and 3/4 and 5/4, what do you think comes next? 1, 3, 5, 7, 9, 11. You understand what we're doing? We're just moving up 2 at a time and putting it over 4. So if my common difference is what, 2/4? But if I take negative 1/4 and add 2/4, what do I get? 1/4. So I got this number here. Okay, so now I just keep listening. 7, 9, 11, 13, 15, 17, and there's my 10th term right there, 17/4. So the first term is negative 1/4. The common difference is 2/4. And the 10th term is 17/4. You want to use the formula? Sure, why not? A sub 10 is the first term plus 10 minus 1 times the common difference. So that's negative 1/4 plus 9 that's not right. Oh, 9 over 1. 9 over 1 times 2 over 4 would be 18/4, wouldn't it? Sometimes I can't do it in my head. I have to write them out to see what's going on. So negative 1/4 plus 18/4 would be 17/4. And so that's the 10th term. Now, look what it says for problems 11 through 20. Where's my bottle of water? Allergy time. That's right. It's so funny. I've had allergies all my life. But now that I'm old, I start coughing like that at home. My wife goes, "Are you okay? Are you okay?" Like I'm dying or something. You know? I'm going, "No, I'm dying." Okay. For 11 through 20, now S sub 10 means find the sum of the first 10 terms. So what that means is for problem number 12, which is really problem number 2, and problem 2 wasn't it 3, 6, 9, 12, 15, 18, 21, 24, 27, 30? So, any idea what I'm going to do to find the sum of those 10 numbers? Turn on my calculator and go 3 plus 6 plus 9 plus 12 plus 15 plus 18 plus 21 plus 24 plus 27 plus 30. And I just got 165. Well, let's use the formula and see if I did it right. The formula is on page 314. And it says the sum of the first n terms is n times a sub 1 plus a sub n divided by 2. So s sub 10 would be 10 times a sub 1, which is 3. That's the first term. Plus the 10th term, which was 30. Everybody see that? Divided by 2. So what's 3 plus 30? 33 times 10, 330, divided by 2, 165. So how would you rather work these? Just string them out there and get a calculator and add them up? Or use the formula? Oh, I have to show you something. This is so cool. I'm going to change to blue. This is just so cool. Watch this. What's 30 plus 3?
33.
What's 27 plus 6?
33.
What's 24 plus 9?
33.
Everybody see what's going on? What's 21 plus 12?
33.
And what's 18 plus 15?
33.
And since there's 10 numbers here, how many pairs do I have? 1, 2, 3, 4, 5, which should be 10 divided by 2. Is that cool? I mean, that's just like a piece of art that ought to be down in the Nelson Art Gallery for everybody to look at. Don't you think? I mean, that's just cool stuff. That's where this formula comes from. You don't even care. You just want to know how to get the answer. Okay, I'll show you how to get the answers. Number 14, which was number 4. And it was 3, -1, -5, -9, up to -33. So what's your choice? Add them all up with a calculator or use the formula? On the count of 3, say something. Say formula or add them. 1, 2, 3.
Formula.
Did I hear formula? Did I hear formula? All right, let's do the formula. S sub 10 is 10 times the first term plus the 10th term. So I have to have the 10th term divided by 2. So that's 3 plus -33 would be -30. Let's go over here and work it. -30 divided by 2 times 10. Or I could just take 2 into 10 and get 5, and I get -150. Everybody follow that? That's pretty straightforward, isn't it? So those of you who didn't want to use the formula, just get your little calculator out and punch in all those numbers and you'll get the answer. Have I just convinced you to use a formula? All right, how cool is that? Number 16, which was what, number 6? 2/3, 5/6, 1, and remember what I did with that one is I just changed them all to 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the 10th term. So the formula would say S sub 10 is 10 times the first term, 2/3, or 4/6, either one, times the 10th term, which is 13/6, divided by 2. Let's just take the 2 into the 5. The 2 into the 10 and get 5. That'll make it easier for us to work through it. So now all I have to do is add 2/3 and 13/6. And what was 2/3? 4/6. And 13/6 is 17/6. And take that times 5, and what do I get? $85/6. Is that what I get here? $170/12? What's 170/12? That's not going to come out even. 170/12 is, divided by 2, 85/6. So how are they going to show the answer on that one? Are they going to leave it 85/6, or are they going to change it to 14 1/6? Would it matter to you how they said it? Would you know that 14 1/6 is the same as 85/6? So if you're taking a test and you say, hey, if I leave my answer like this, which I would because I like fractions, and then look at the back and it said 14 1/6, I'd go, well, 14 1/6 would be 4 6s is 24. That's 84 plus 1/6. So that's the same as my 85/6. So I have the correct answer. Number 18 is problem number 8. -1/4. Oh, and the same thing here. See where it says in problems 11 through 20, find S sub 10 and S sub n. Mark out S sub n. We're only doing S sub 10. We're not doing that S sub n stuff. So S sub 10 would be 10 times the first term plus the 10th term, which is 17/4. So what's 17/4 plus -1/4? That's 16/4, isn't it? Oh, that's 4. What's 4 divided by 2 times 10? 20. So the sum of the first 10 terms, you go, wait a minute, you're going to add all those fractions up and get 20? Well, if you don't believe me, buy a calculator that does fractions and enter them all in there. But the answer is yes, that's what you'll get. Or change them all to decimals and then add them all up and you'll get 20. Problems 21 to 26 tell us to find geometric sequences. And they just tell you, for this section, these are geometric. But you can tell that anyway by looking at it. And then again, skip D, only do A, B, and C. But these are geometric sequences. Let's see, how do I get from 5 to 15? You say add 10. Then how do I get from 15 to 45? You say, if I added 10, I'm only up to 25. So you say, hey, this is more powerful than addition. So I go times 3. And times 3, and times 3, and times 3. And I just keep listing them all out there. And is that the 10th one? 1, 2, 3, 4, 5, 6, 7, 8, 9. There it is. There's the 10th one right there. 98,415. Page 315 shows the formula. It's a different formula. The formula for finding the nth term. The 10th term. The first term is 5. The common ratio, that's the thing you multiply by, is times 3. The 10th term is the first term, 5, times the common ratio to the n minus 1 power. So that means this is 3 to the 9th. How do you get 3 to the 9th? You go 3 times 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 3 equals 19,683. And if you take that times 5, you get 98,415. Do some of you have calculators that do exponents for you? So you don't have to count them out like that and just do them over and over again on your little cheap calculator, like I have here. Okay. So here again, there are two ways to find the 10th term. Just keep multiplying by 3 and list them all out there, or use the formula. You know what? If you have to use a calculator like mine and keep doing 3 times 3 times 3 times 3, I'm thinking I'll just multiply them out. And that's okay if you want to do it that way. Problem 24 says 1/5, and then 1, and then 5, and then 25. Now, see, you say, I don't like fractions. Okay, just go from 1 to 5 to 25. What did I do? Times 5, times 5, times 5. 25 times 5 is 125. So it's going to be times 5 for the first one too, isn't it? And sure enough, 1/5 times 5 over 1 equals 1. Okay. So, what's the first term? 1/5. What's the common ratio? 5. What's the 10th term? That's what they want to know. So you just keep multiplying by 5 till you get out to the 10th term. Just make 10 little blanks and fill them in there. And if your blanks aren't wide enough, just write it sideways till you get 390,625. And if you want to use the formula, then a sub 10 is the first term, 1/5, times the common ratio, 5 to the 10 minus 1 power, which would be 5 to the 9th. And what is 5 to the 9th? 1,953,125. And then times 1/5 would be the same as dividing that by 5, and you would get 390,625. 390,625. Any questions? Is this perfectly clear? (26) 3. Okay, if it's not obvious, watch what I do here. 3 times something equals -1. I'm looking for the common ratio. Or I could say -1 times something equals 1/3. You follow me? So what would I take times 3 to get -1? -1/3, right? Because that would be 3 over 1. What do I take times -1 to get 1/3? -1/3. Everybody follow that? So what's my common ratio? -1/3. Where'd it go? Didn't put it in here? Oh, here. A is 3, B is negative 1/3, and C is the 10th term. And how do I get that? A sub 10 is the first term times the common ratio to the 10 minus 1 power. That's to the 9th. So what's negative 1/3 to the 9th? What's it going to end up being? Well, it's going to be what? 3 times 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 3. What does that come out to be? 3 times 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 3 equals 19,683. And a negative to the 9th power would be, that's positive, that's positive, that's positive, that's positive, and then times that last one is going to make it negative. Everybody see that? When you have a negative number to an odd exponent, it's going to be negative. If you have a negative number to an even exponent, it's going to be positive. So now I have 3 over 1 times this, and so I divide this by 3, and I get negative 1 over 6561. And that's the 10th term. And you say, I could have just strung them out here and kept multiplying by negative 3. What would be the next one? Or negative 1/3? That would be 1 over 27. And then what's next? Let's change it to red. No, let's change it to black just for fun. That'd be 1 over 27. Then the next one would be 1 over, or negative 1 over 81. Next one would be 1 over 243. See what's going on? See how you would just keep going? 1, 2, 3, 4, 5, 6, 7. Negative 1 over, what would that be? 9. 3 4s is 12. 729. And the next one would be 1 over 729 times 3. 2187. And the next one would be negative 1 over 2187 times 3. 6561. All right. Number 27 through 32 says find the sum of the first 10 terms. So that just means for this number, that means for this number we just worked here, well, let's just move down here and work through them. For 28, which is the same as 22, let's go back to blue. I like blue this morning. 22, 5, 15, 45, 135. You just take that big list and add them all up. Or you use the formula. Here's why I like the formula for these problems. Look what it says to do. In problems 27 through 32, find S sub 10, forget about S sub n, for the sequences given in problems 21 to 26. and give your answers in simplified exponential form. So when you look in the answer key to grade them, they're going to show the answer in exponential form. So I'm going to use the formula. So it's S sub n is a sub 1 times parentheses 1 minus r to the nth power divided by 1 minus r. And r is the common ratio. So for number 22, S sub 10, the first term is 5. The common ratio is 3. And so it's 1 minus 3 to the 10th power divided by 1 minus 3. The common ratio. Everybody see where I'm getting my numbers? So I have 5. I don't need to work all that out. 1 minus 3 is negative 2. So I have 5 over negative 2 times 1 minus 3 to the 10th. So I'm done. Here's my answer. Negative 5 halves times 1 minus 3 to the 10th. Because they say show your answers in exponential form. So there's my answer. And I'm done with it. Except when I looked in the answer key, this is what it had for an answer. Does this answer look like my answer? It doesn't? Well, watch what happens. If I take this, I'll change to green. If I take this times negative 1 and this times negative 1, if I take negative 1 times negative 1, that's just the same as 1, isn't it? What's negative 5 halves times negative 1? 5 halves. What's 1 minus 3 to the 10th times negative 1? Negative 1 plus 3 to the 10th. So that's why the answer key says 5 halves plus 3 to the 10th minus 1. Negative 1 plus 3 to the 10th is the same as 3 to the 10th minus 1. So this answer, the keyed answer, and this answer say the same thing. So when you do this stuff and you grade your homework, don't be too quick to check it wrong. It could be that the guy who wrote the answers just didn't like that negative out there in front. So which do you think looks prettier? The stuff in blue or the stuff in red? So the guy who's doing the answer key just rearranges things. He doesn't arbitrarily do it. He does it by multiplying each term by negative 1. Well, that's going to be the part of this that you're not going to like. It's because sometimes they dress up the answers just because they like to, instead of leaving it in a straightforward form that looks like what you got for an answer. Okay, problem number 30 is the same as 24. The sum of the first 10 terms, let's go back to blue, is the first term, 1/5, times 1 minus the common ratio, 5 to the 10th power, over 1 minus 5. So that becomes 1/5 times 1 minus 5 to the 10th over negative 4. What's 1/5 over negative 4 over 1? That's 1/20. Times what? 1 minus 5 to the 10th. And what's the answer key going to say? Oh, that's negative 1/20. So there's my answer. But what's the answer key going to say? It's going to say 1/20 times and negative 1 plus 5 to the 10th, which is the same as 5 to the 10th minus 1. Okay. See what they're doing to rearrange things? Because that's what the answer key said when I looked at the answer key. And I could tell by looking at that this answer and my answer are the same. But if it doesn't look the same to you, then here's how you rearrange it. By taking both parts, taking this part and this part, times negative 1. Number 32, which is what? If that was 24, then this is 26. 3, negative 1. The sum of the first 10 terms would be the first term times 1 minus the common ratio, 1/3 to the 10th power, and then 1 minus negative 1/3. Sorry, the common ratio was negative 1/3. Divided by 1 minus negative 1/3. So that comes out to be 3 times 1 minus, why did I put 1 over 3 to the 10th? What's negative 1/3 times negative 1/3 out 10 times? Well, 10 even exponent, it's going to come out to be a positive answer, and it's going to have 1 on top and 3 to the 10th underneath. And then what's 3/3 plus 1/3? That equals 4/3. That's a third. 3/3 plus 1/3 is 4/3. So now I have 3 divided by 4/3. What does that come out to be? 3 over 1 divided by 4/3 is 3 over 1 times 3/4. So that's 9/4 times 1 minus 1 over 3 to the 10th. Not 33 to the 10th. If you want to leave your answers in exponential form, which is the way they want you to show it. Okay? There it is, right there. 9/4 times 1 minus 1 over 3 to the 10th. skip problems 33 to 39. I figure if you get a handle on arithmetic sequences and geometric sequences, you've got a good handle on this sequence stuff, so you don't have to go to the third level and do infinite geometric sequences. I'll show you one in a little bit, but just skip problems 33 to 39 because it takes too much time. And I don't think there's any place in the future where you're going to see that unless you take more math. And if you do, then they'll walk you through the process then. So let's do some story problems. 42. Strikers at a plant were ordered to return to work and were told they would be fined $100 the first day. So there's my $100 for the first day. $150 the second day. And $200 the third day. And so on. So you know what and so on means? What's it going to be the fourth day? What's the, from 100 to 150 is plus 50. From 150 to 200 is plus 50. So what's the next one going to be? Plus 50 again. So it's going to be up to 250. Then up to 300, up to 350, up to 400. Have we gone far enough yet? If the strikers stayed out 10 days, 1, 2, 3, 4, 5, 6, 7, I didn't go far enough. 8, 9, 10. There's the 10th day. Oh, because I want you to use the formula? No, you don't have to use the formula. I mean, can you see when you've done that many, it's easy just to walk it on out there? So what would be the fine on the 10th day? $550. Go back to blue. $550. What would be their total fine? Well, I would just add, get my calculator. I mean, isn't that what you would do if you're working a story problem? Just go 550 plus 500 plus 450 plus 400 plus 350 plus 300 plus 250 plus 200 plus 150 plus 100. $3,250. Same if I would have used the sum of the first 10 is 10 times the first one, 100, plus the 10th one, 550, divided by 2. $3,250. Time to go back to work. Stop at number 43. But I did number 44 just for fun. To show you how this infinite geometric sequence works, look at number 44. Even though you don't have to know how to do this. When dropped on a hard surface, a super ball takes a series of bounces. So here's the ball up here, and we dropped it. And when it dropped, it bounced back. It only bounced back, if it dropped 10 feet, it only bounced back 9 feet. Because it bounces back. See what it says? 9/10 as high. And so then that means the second time it bounces back. Bounces, that's 9 feet. Then the next time it bounces back, that's only 8.1. 9 times 9, 9/10 of 9. And then the next time it bounces back, that's only 7.29. And it just keeps bouncing and bouncing and bouncing and bouncing and bouncing and bouncing. And I just kept, because this tablet lets you do that, I just kept running this stuff out there till, wow, it's bouncing where it's less than a half an inch. And then it's less than a quarter of an inch. And then it's down to where you can't even see it moving. Just keeps on going and going. And eventually it stops somewhere, doesn't it?
Probably not.
My goodness. How far out did I go with this thing? I don't have enough to do over the weekend, do I? Wow. You probably picked it up before it quit bouncing because you thought it quit bouncing. Anyway, then I got to the end of those numbers and I started adding them all together. And all of these numbers adding this way, all those numbers add up to 3/10. And then if you keep adding these numbers, you get 6/10. And then if you keep adding the 6/10, you get up here, you get to 1. And then from 1, you get to 2 here. And from 2, you add these numbers, you're up to 4. From 4, you're up to 8. From 8, you're up to 15. See, 8, 9, 10, 11, 12, 13, 14. And then those fractions in there make 15. From 15 up to 20. From 20 up to 31. From 31 up to 53. From 53 up to 90. So those little blue bounces, all those add up to 90. But when it bounced up, it also fell back down. So I have to take those 90 times 2 to get the total distance the ball went. And that comes up to 180. But I've got to add in the 10 when I held it up and dropped it. So that makes the total distance this little super ball traveled to be 190 feet. And can you see where what I just did is a lot more work than if you just take the formula for an infinite geometric sequence, which is on page, what was that? How come I didn't write it down there? Page 316. It's on page 316. And a sub 10 is 9 times 0.9 to the 9th. Oh, here it is. So the sum of the infinite geometric sequence is a 9 times divided by 1 minus 9/10, which is 90. And then I had to double them times 2 and then add that 10 in where I dropped it to begin with to get to the final answer of 190. Wasn't that fun? I had fun doing it. So anyway, you stop at 43 because I don't want you to have to mess with geometric sequences. And have a nice day. And thank you for coming this morning. Have you figured out we finished the chapter? So on Wednesday, we're going to do the practice test. And then Friday, you don't have school, right? Yep. So Monday, we'll take the exam.